Hello everyone. In this video we're going to be solving a polynomial system. We have a squared minus b squared equals 24 and ab equals 35. And we're going to be looking for a and b values. I'll be presenting two methods and then we're going to take a look at the graph of these two functions. So let's start with the first method. My first method is basically can be summarized as substitution, and the second method involves some algebraic manipulations or some identities. So for the first method, I'm going to isolate b, so I'll write b as 35 over a. Notice that a equals 0 does not work, so we can divide by a, and we're going to go ahead and substitute this into the first equation, which is this one. So if you do that, we get a squared minus 35 over a squared equals 24. If you square 35, but I believe in one of the videos we talked about this, if I remember correctly. If not, then we'll talk about it. To square a number that ends in 5, we're going to take the 3 and multiply it by 1 more than the number, which is 4. So 3 times 4 is 12, and we'll just attach 25 and we'll be done. So that's how you can easily square 35, and this is equal to 24. Now at this point I'm going to use substitution one more time because this is going to turn into a biquadratic or a quartic equation with no a cubed in it. So we can write, basically set a squared equal to c, and then that gives us c minus 1225 divided by c equals 24. Multiplication by c gives us c squared minus 1225 equals 24c. Now if you put everything on the same side, like we can kind of do the following. Isolate 1225 on the right hand side and bring the c over to the left hand side, and then complete the square. Now remember, for completing the square method, we add half of the middle coefficient squared. So half of 24 is 12. We're just gonna square that number, and that is 144. If we add 144 on the right hand side, we get 1369. Now the left hand side becomes a perfect square, which can be written as c minus 12 squared. And 1369 is also a perfect square. If you're wondering what that is, it is 37 squared. Now this is nice. It kind of indicates that the solutions are integers. It doesn't always happen. Sometimes you get an irrational number. So from here we can say the following. C minus 12 is either 37 or c minus 12 is negative 37. Great. So let's go ahead and take a look at each case. If c minus 12 is 37, that means c is equal to 49. But remember what c was, right? C is a squared. So we can kind of set this equal to a squared. And a squared equals 49 gives us two solutions, a equals 7 or a equals negative 7. Great. Let's go ahead and take a look at the other scenario. Adding 12, we get c equals negative 25. Set it equal to a squared. You don't get real solutions. You get complex or imaginary solutions, and they're going to be a equals 5i and a equals negative 5i. Remember recently, I think it was yesterday, right? We talked about I, not just I, but I to the power I. Okay. So we got these four solutions. Obviously, if a is something, then b is going to be something else. How do you find the b value? Well, we do know that their product is 35. Remember that? AB is 35. So if we know A, B is easy to find. If A is 7, B is 5. If A is negative 7, then B is going to be negative 5. So that's going to be our solution pairs. But what about the imaginary cases? If A is 5i, think about a value that you would multiply by 5i to get 35. Obviously, that will be 7i would give us negative 35, so it's supposed to be negative 7i. And from here, you're supposed to get 7i. Because when you multiply 5i and negative 7i, you get negative 35i squared, which is positive 35. Because you have to consider the fact that I squared equals negative 1. Okay, great. So those are all the solutions, real and complex. And let's go ahead and take a look at the second solution. And then we're going to look at the graph. Great. So here's the second method. For my second method, then let me rewrite the original system. Now, here's our system, and for the second method, I'm going to take advantage of some identities. First of all, a squared minus b squared kind of gives me the idea of using difference of two squares. So a squared minus b squared can be factored into a plus b times a minus b. And this is equal to 24. Now the presence of a plus b and a minus b together in the same equation, and the fact that we're given ab, also gives me another idea, which is a plus b squared minus a minus b squared equals, now this is an identity that's not well known, but it's very helpful. Notice that this is going to give us a squared plus b squared plus 2ab, and this is going to be a squared plus b squared minus 2ab. So what happens is these two cancel out. We end up with 2ab minus negative 2ab, which is 4ab. That's kind of cool because it associates the difference and the sum with the product. That's why I really like this identity. Okay, what am I going to do with this? Well, we're going to use substitution again. So it's like substitution within the second method. So I'm going to set this equal to x and this equal to y. And now this gives me xy equals 24, and x squared minus y squared equals 4 times. By the way, we do know ab. ab is equal to 35, so this is actually equal to 140. Now, this gives us another system, and guess what? This system is very similar to the original problem, except the original one was this, right? And this is kind of like switched around a little bit. Anyways, so this is what we're going to try to solve, and then we'll go back to a and b. But how do you solve it? Well, we kind of used a method. With the first method, we used an approach, but let's slightly modify it. So I'm going to go ahead and square both sides here. 24 squared is 576. And then I'd like to use substitution one more time. Let's go ahead and isolate maybe x squared or y squared, but we could also do the following. Let's go ahead and, I know this is kind of unusual, but let's write the x squared minus y squared as x squared plus negative y squared. And you'll see why this is helpful. And here, I want to form the quadratic equation whose roots are x squared and negative y squared. So I need a negative y squared. Let's multiply both sides by negative 1. So kind of keep it like this, and that's going to be negative 576. Now, these two basically give me the sum and the product of the roots. So by using Vieta's formulas, by the way, I have a lecture video on it. I'll share the link down below. So we can go ahead and write the following. If we have an equation whose roots are x squared and negative y squared, then that equation is going to look like this. T squared minus 140t minus 576 equals 0. So that's by Vieta's formulas. We know the sum and the product. And now we're looking for two numbers whose product is negative 576 and whose sum is negative 142. I know that's a mouthful, but those numbers are negative 144 and positive 4 because their sum is negative 140 and their product is negative 576. So we can write this as t minus 144 times t plus 4 equals 0. And from here, t equals 144 or t equals negative 4. But what is t? Remember what t was? T is either x squared or negative y squared. We could just use one of these because the roots are going to switch around. So let's go ahead and set this equal to one of the roots of this equation, which is x squared. So x squared equals 144 gives us x equals 12 or x equals negative 12, right? Okay, great. T equals negative 4 and that's equal to x squared. That gives us x is 2i or x is negative 2i. Now, if x is equal to 12, what do we know, right? We do know that xy is equal to 24. So if x is 12, then y is 2. If x is negative 12, then y is negative 2. If x is 2i, then y is, what is it going to be? We got to find 12i. 12i is going to give us negative 24, so then negative 12i. And y is going to be here 12i. So those are going to be the solutions, but we're not looking for x and y. Remember that. We're looking for a and b. How are they related, right? Okay, so here's the association between a, b, and x. We said that a plus b is x and a minus b is y. So we do know the x and y values. So for example, if x is 12 and y is 2, then we get the following system. We can just add these up, and a equals 7 and b equals 5. So we're going to basically get all the solutions. Same way, let's go ahead and write them as ordered pairs, and I'm going to show you the graph. 7 comma 5, negative 7 comma negative 5, and then 5i comma negative 7i, and negative 5i comma 7i. And here's the graph of these two hyperbolas. Now you might be wondering, why are these equations so different if they're both hyperbolas? Because the first one is a normal hyperbola, the second one has been rotated 45 degrees. And if you rotate some parabolas, that's what happens. Well, this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.